In this video, we will talk about references and pointers in C++, but it will mostly be about references. First, let's recall how we can pass vectors to functions. We can have a vector as the argument to a function, just like an ordinary variable, like a double, an integer, and so on. You can have a vector of integers or doubles. So this particular function called the output is going to print the components of a vector on the screen. So there's no return type, it doesn't return any value, so the return type is void, it doesn't return anything, but it prints values to the screen. And the argument type here is a vector of integers. So if I declare in my main function a vector of integers w, and then call that function and pass that vector w to the function, then that function output will take the components of that vector through this for loop and print each component one by one to the screen. Now, if you try and do that with an argument type that does not match, you're going to get an error. So in this example, we have declared that the argument of the function is a vector of integers, and we passed a vector of integers. But if we declare that the argument is a vector of integers and we try to pass a vector of doubles, then the compiler will complain. The program will not compile. So the argument type has to match, obviously. Now let's consider another example of passing a vector to a function. This function is called sum, and we're passing a vector of doubles to it. And what this function does is it sums over these components of the vector inside using a for loop, and then returns the sum. And the return type is a double, so this time it doesn't print it to the screen, it just returns a value s, which is the sum of the vector components. So if I declare a vector of doubles w with components 4 and 3, and I pass that vector, and we pass that vector w to that function, then the function will calculate the sum and return it, and then we are printing that quantity to the screen. Now, if we do this, then essentially what happens is we have a vector w stored in memory, and when we are passing that vector to that function, sum, then the program is making a copy of that vector inside the function and stores it at a different part of the computer's memory, and then is using that copy to make computations inside the function. So that's what happens in all the examples that we have seen so far. What we've done is called passing to functions by value. So in these examples, both for vector and plain data types, like integers and doubles, the function arguments are passed by value. This means that a copy of the variable is made inside the function. In general, this is not a problem for plain data types, but it may be slow for a large data structure, like a very large vector or a very large array. And any changes to the variable inside the function have no effect outside the function. So let's consider one more example of passing by value, and then we will see another way of passing by reference. In this case, I have a function that takes an integer k as an argument. And in my main function, I declare an integer m, and I initialize it to the value 2. And then I call the function add1 and pass this value m to the function. In this case, k is a copy of m. In other words, it's initialized with the same value. K is then increased by 1 inside the function, but then it goes out of scope when we exit the function. So the variable k is not readable outside the function. So we say that it goes out of scope. So this change of the value of k doesn't have any effect after we call this function. What we could do instead, and that would be more efficient, is instead of passing by value, we can pass by reference. What does that mean? In practice, we just put an ampersand in front of the function argument. So this ampersand, you can think of that as meaning address of. If we do this, then the value of m will be increased. To understand why this happens, we must understand what this ampersand means exactly. When we create a variable, such as k, we create it at a specific location in the processor's memory. A reference is that location in memory. So in this example, if I define an integer k equals 2 and I print that integer to the screen, then ampersand of k is the location of k in memory. So you can think of that as address of k. So let's code this up real quick. So here I have opened Xcode. I'm going to select macOS and command line tool, and I'll select the product name. Let's call it reference. And let's save it to the desktop. Okay, so it has created the main CPP file. And as usual, Xcode created a Hello World program for us. Let's just build it and run it once. Okay, so here's the Hello World. And now I'm just going to copy and paste some of these commands. So first of all, I need, as usual, using namespace standard library. And then let's delete this code and write, let's declare an integer k, and where were we? We were here. And let's try cout k, and then end the line. And let's try cout address of k, and the line. And we don't need this anymore. So let's run it. So what we see here, cout k gives us the number 2 as expected, and this strange number here, it's essentially the address register for it's for the number for the variable k. So it's the location in memory where the variable k is stored. Now, in this example, let's create another integer m that's also equal to 2, and let's also print that one out to the screen and print the address of m. Now, what is going to happen if we do this is that, of course, when I print k and m to the screen, I'm going to get the same number, which is 2, but the variable k and the variable m are stored in different locations in memory. So when I ask for the address of k and the address of m, I'm going to get different numbers or different locations. So you see, indeed, so that's the location of k, and this is the location of m, and they're very nearby in memory. They're stored very close to each other, but they're not at the same place exactly in memory, so they're slightly different. Now, one can have standalone reference variables like m below. So let's code up this piece of code and see what happens. So I'm gonna have an integer k and then integer ampersand m equal to k, and then integer star. Now, star is a pointer that's related to the reference, and in some sense it's the inverse of a reference. So this is widely used in C-style programming, but we are not going to make much use of it in this course. So I'm just mentioning this in passing, but we may explain it in more detail later, but we're not going to use it. But we are going to use references, so we are going to use mainly passing by reference. Okay, so let's do the next command, which is k++. And then let's try to cout k and m and pointer p. Okay, so we see that we get the same result in all three cases. So in this case, m is a reference variable and p is a pointer variable. Okay, so passing to functions by reference is essentially the only use of references or pointers that we will need in this course. This will allow the value of the arguments to be changed, and it avoids copying large data structures. Now, let's suppose we want to change just one variable. If I wanted to change just one variable, one argument, then I could have the function return a value k to do this. But if I want to change more variables, it's not as easy. So in this case, I have this function add1. I pass the number m equals 2, and let's check what happens. Okay, so we coded up this piece of code, and when I run it, we get k in add1 is 3 in this function, and then m in the main function is also 3. So by doing this, we managed to change the value of m and increase it by 1. If I want to do that to multiple values, I may have to return multiple values. This is possible in C++ 20, and we will see how to do that later. But for now, by passing by reference, we can very easily change more than one variables. So let's see how to do that. Okay, so we typed up this code. So here we have the reference or the address of m and the address of n, and here in the main function we define two integers, a equals 2, b equals 3, and we call the function swap, and we pass a and b to that function, but that function will just read the address of a and the address of b, because the arguments here in that function are the references. So that's the reference m and the reference n. And what this function does here is it defines a temporary variable s, which equals n, and then it changes and sets n equal to m and m equal to s. So it changes the address, it swaps the address of those two variables in memory. So let's see what happens if we run this code. So as you can see here, we define a equals 2 and b equals 3, and once we call the swap function, then a and b swap places with each other because they traded places in memory, essentially. So if I print out a, I get 3, and if I print out b, I get 2. Now, in general, there may be some arguments that are to be changed and some other arguments that are not to be changed. By convention, if we have both of those kinds of arguments, the ones that are to be changed go last, and the ones that are not to be changed go first. This is just a convention. A constant reference argument would count among the arguments not to be changed in this case. A function that changes its arguments, like the one we just showed, can be confusing. So it is better to just return values where possible. This might mean breaking functions into smaller pieces and doing things in a more modular way. Now, if we don't want to change the argument, which syntax should we use? The plain data types, like a double or an integer, can be copied with little computational cost. So these should be passed by value. It is more costly to copy data structures, such as a vector or an array, which may be very large. So these should typically be passed by reference. we should normally make the argument a constant reference to avoid changing it by mistake. So if we make a mistake and change it, the compiler is gonna give us an error and say this is a constant and you shouldn't change it. So this will just protect us from making mistakes. Now, how do I make a constant reference? Well, reference arguments are made constant just like plain arguments. So in this example, I might have a vector double and then address of v here. I can just put a constant in front of it, and that will ensure that this argument is not going to change during the function evaluations here. So this is an improvement of the function I showed earlier, which calculates the sum of the components of a vector. This function is going to be more efficient when you pass a very large vector to it. It's not going to make a copy of the vector like it did before. Instead, it's just going to read that vector from the memory where it's already located without making a copy. It will just read it directly and start making calculations. So doing that is much more efficient, especially if this vector w is very large, with millions or billions of components. Okay, so let's summarize the function types we have discussed. So this function here, sum vector double v, copies the vector and may change the copy inside the function, but this has no effect on the vector that was passed to the function. On the other hand, this sum constant vector double v, it cannot change the copy that we passed to this function because the argument is a constant. Now, this function here, sum vector double address of v, is a bit more dangerous. This function accesses the vector, which is outside the function, directly from where it's stored in the computer's memory. And it may change this vector v by accessing it directly. This function, on the other hand, some constant vector double address of v, it again accesses the vector which is outside the function directly from the memory, but it cannot change it because we have declared the argument here to be constant. For a vector, we generally want to use the last of these functions for obvious reasons. So first of all, because it's more efficient to access the vector directly instead of making a copy, and it's safer because the argument is a constant, so we don't change that vector. We just do work with it, but we don't change it directly. And by do work with it, I mean the function is calculating things using the components of the vector and so on, but it doesn't change the components of the vector. For example, it calculates the sum of all the components and returns that. And of course, in this example, we looked at having one argument or one vector as an argument. But just as with plain data types, we can have multiple arguments and we can mix argument types. For example, we can have two vectors, u and v, that are input, or the addresses of those vectors, and then we can calculate the inner product, which is u dotted onto v, for example, and that's the sum of ui vi. So that's the usual inner product or the dot product of two vectors. It can be calculated efficiently in this way. So this is it for today's video. Thank you for watching.